Hey everyone, welcome back to my channel. In today's video, we're building an AI chatbot called StudyMate, a smart study assistant that helps students extract information from PDFs and websites to generate structured study notes. Imagine being able to take any study material, feed it into an AI, and get instant summaries, definitions, key points, and real-world examples. Sounds exciting, right? Let's get started. Step 1. Importing the required libraries. First, let's import all the necessary libraries that will help us build our chatbot. Here's a quick breakdown of the most important libraries. Streamlit, STI, to create an interactive web app. PyPDF2, PDF reader, to extract text from PDFs. LangChain, web base loader, recursive character text splitter, retrieval QA, to process documents and create an AI-powered retrieval system. Hugging Face inference API embeddings. Hugging Face Hub, to generate embeddings and use an AI language model. Google Gemini AI, chat Google Generative AI, to generate AI-powered responses. ChromaDB, to store and retrieve processed documents efficiently. Step 2. Setting up API keys. Next, we need to set up our API keys for Hugging Face and Google's Gemini AI. These keys authenticate our chatbot with external AI services. Make sure to replace your Hugging Face API token and your Google API key with your actual API keys. Step 3. Creating the Streamlit interface. Now let's create a simple and user-friendly interface using Streamlit. We set up a sidebar where users can choose whether they want to input a URL or upload a PDF. This will allow StudyMate to fetch relevant study material based on the selected option. Step 4. Handling URL and PDF uploads. Now we handle the input data. If the user chooses a URL, we extract text from the web. If they upload a PDF, we extract text from the document. Here's how this step works. 1. For URLs, the user enters one or more website links. The script loads the content from these web pages using Web Base Loader. If an invalid URL is entered, an error message is displayed. 2. For PDFs, the user uploads one or more PDF files. We extract text from each page using PyPDF2. The extracted text is then stored for further processing. This step ensures that our chatbot can work with both web-based and document-based study materials. Step 5. Processing and storing data in a vector database. Now that we have extracted text from the PDFs or URLs, we need to process it and store it in a way that allows efficient searching and retrieval. This is where text splitting and vector embeddings come into play. Here's how this step works. 1. Recursive character text splitter splits large documents into smaller chunks while maintaining context. Hugging Face embeddings converts text into a vector representation to help in semantic search. Chroma Vector Store stores the processed document embeddings and allows efficient retrieval. Retriever fetches the most relevant document chunks when a query is asked. Step 6. Setting up the AI model. Now that our text data is stored in a searchable format, let's define our AI model to generate responses. Here, we are using Google's Gemini AI to generate responses. The model we selected is Gemini 1.5 Flash, which is optimized for speed and accuracy. Why Gemini AI? High-quality responses based on context. Fast inference speed for real-time interactions. Optimized for natural language understanding and summarization. Step 7. Building the chatbot interface. Now let's create the chatbot interface where students can ask questions and get AI-generated study notes. Let's break this down step by step. 1. Chat history initialization. S.SessionState messages stores previous conversations so users can see their chat history. User input handling. st.chatInput type your message collects the user's query. The input is stored in st.SessionState messages. 3. Retrieving relevant documents. Retriever.getRelevantDocuments user input fetches the most relevant chunks based on the question. These chunks are then combined into a single context for the AI model. 4. Generating AI responses. A structured prompt is created using prompt template. LangChain processes the prompt and generates an AI response. The AI's response is displayed in the chat interface. With this step, our AI chatbot is now fully functional and can interact with students in real time. Step 8. How to run the code. Now that we've built StudyMate, let's see how you can run it on your local system. Follow these steps. Install the required dependencies. 2. Run the Streamlit app. 3. Interact with StudyMate. Open your browser and go to the local URL displayed in the terminal. Choose PDF or URL as input and start chatting with your AI-powered study assistant. That's it. We've successfully built and deployed StudyMate, an AI-powered study assistant that extracts and organizes information from PDFs and websites. The full version of the code is available in the description on my GitHub. Hope you found this tutorial helpful. Like and subscribe if you enjoyed the video. Turn on notifications for more AI tutorials. Thanks for watching, and I'll see you in the next one.